So today our goal is to do some exponential equations and logarithmic equations, and since we know the rules of logarithms, hopefully, and properties, let's apply some of them. So let's look at number 2. We have 3x is equal to 81. Well, what this is asking us, obviously, is what power do we raise 3 to get 81? Well, you might know that that's 3 to the 4th is equal to 81. But another way to do this is to say this is 3x is equal to 3 to the 4th. And then from there, you can see that x must equal 4. Okay, so let's look at number 5 now. We have 2 to the 2x minus 1 is equal to 32. Oops. So what does that mean? Well, 32, we know that can be rewritten as 2 to the 5th power, because 2 times 2, 5 times is 32. So what does that mean? That means 2x minus 1 is equal to 5. So if we solve this, x is equal to 3. Okay, so pretty simple. Just takes a little bit of practice and getting used to. We have 3 to the x, 2x plus 1 is equal to 27. That means 3 to the 2x plus 1 is equal to 3 to the 3rd. 2x plus 1 is equal to 3. And then x is equal to 1. Now in this case, we don't have to check these solutions because the domain of exponential functions is defined among all real numbers. And so we don't have to worry about any of these being incorrect. Let's keep going. Let's do 10, for instance. We have 4 to the x is equal to 32. Well, in this case, 4 doesn't have a power that goes into 32. So what do you think we should do? Well, these both have powers of 2, or both are powers of 2. So this is 2 squared to the 4th. Oops, 2 squared to the x is equal to 2 to the 5th. Now we know the power rule says if you raise a power to a power, you multiply them. So this is 2x is equal to 5. We divide by 2, we get x is 5/2, which means it is a square root, and then you're raising the inside to a 5th power. Let's do 12. We have 125x is 625. Well, these are both powers of 5. 5 to the 3rd x is equal to 5 to the 4th. So 3x is equal to 4, or x is equal to 4/3. And then last but not least, we have 5 to the 2 minus x is equal to 1 over 125. Well, we know this is 5 to the 2 minus x is equal to 5 to the negative 3. And so 2 minus x equals negative 3 means negative x is equal to negative 5, or oops, x is 5. Okay, so this one should be good. This was obviously 14. So now we're going to get into logarithmic equations. If we want to do logarithmic equations, then we have log base 3 x is equal to 4. So we can rewrite this as a exponential equation. Remember, this means 3 to the 4th is equal to x, which means x is equal to 81. Okay, since 81 falls in the range and is positive, this has to be positive or 0. Actually, no, it can't even be 0. Sorry, I forgot. It can't be 0. Since that's positive, we are good to go. We don't have to check this one. 52. We have ln x is equal to 3. Okay, so this is where it gets a little bit trickier. To get rid of ln, you raise it to the power e, or you treat the ln like a power and you raise it to e. So we write e here. this is a power, this is a power. And so now the ln goes away. That means x is equal to e to the third. Now you might say, why does it work that way? Well, remember ln is log base e. And so if we do it that way, then we have e to the third is equal to x. So it works either way. Let's do some of the other ones from before. We have 10x equals 3.91. If we want to get rid of the base 10, we take log base 10. So we go log. And then we go log. I need to make some space. Actually, sorry, I'm doing number 23 from above. Log 3.91. We just simply add that. Now remember the power rule, we write this out in front. We go x times log 10 base 10 is equal to log 3.91. And so this says x equals log base 10 3.91. You don't have to write the base 10. We assume that it's 10 if it's not written. But I'm going to write it just because. Then we're doing e to the x is equal to 5.7. That's number 25 from above. In this case, we're going to take the ln on both sides. Cancels it out. We have x is equal to ln 5.7. So you can see these are kind of quick. Sorry, didn't need that dot. Alrighty, let's get back to the other ones. We have 54. Log 5 base 5 x minus 7 is equal to 2. So this means 5 to the second is equal to x minus 7. This means 25 is equal to x minus 7. And this also means x equals 32. We plug that into here, and you can see that that works out, so we are good to go. It's positive. 57. We have log 3 of x plus 4 is equal to negative 3. Okay, so we have 3 to the negative 3 is equal to x plus 4. This is 1 over 27 is equal to x plus 4. We subtract 4. This is 27 times 4. Wait, oops, that's not 21, that's 28. 108. So this is 108. So 4 is equal to 108 out of 27. If you subtract that, that's 107 out of 27 is equal to x. Sorry, here's what I did. I had 108 over 20. Yeah, over 27 minus 1 over 27, but the 108 is actually the negative. So that's good to go. Is this one positive? Well, we know 4 is 108. So if we add 108 to negative 107, then we get 1 out of 107 or 27, which is good. Let's do 62, 6. What is it? Let's do it over here because I can see it still. We have 6 ln 2x is 30. So let's isolate the ln 2x first. So divide by 6. We have ln 2x is equal to 5. So we do the base e thing, e. This means we have 2x is equal to e to the 5th, divide by 2, divide by 2, x is equal to e to the 5th. Now, you can do that one two ways. This one is a real answer because e to the fifth is positive and 2 times e to the fifth is positive. Sorry, excuse me. I want you to try to do this if you had ln 2x to the 6th power. Try to do it that way if you can. You can still do it. I think it takes a little bit longer though. I want you guys to try it. And then last but not least, let's do 6 plus 2 ln x. Oops. X is equal to 5. We subtract 6. 2 ln x is equal to negative 1. We divide by 2. ln x is equal to negative 1/2. We do e. We have x is equal to e to the negative 1/2. And there you have it. That's it. Thank you guys for watching. I hope you're doing well. Thank you.